Purpose of this video is for us to begin Unit 8. Anytime we begin a unit, we have a lot of vocabulary to talk about. So make sure you're listening, taking notes, and making connections with what we're talking about. The standard form of a quadratic. We just came off of Unit 7, where everything revolved around ax squared plus bx plus c. A quadratic is made by having an equation that has an x squared in it. The graph we call a parabola. Parabola. The parabola can either face up, open up, or open down. Those are only two directions that you'll see the parabola. The parent function, the most simple parabola that can be graphed, is y equals x squared. If we took time to graph that on Desmos, it would very simply be a parabola that faces up, and it would sit right there on the origin. All right, this equation makes this graph. Anytime you see a graph that looks like it's been screenshotted, please know that parabolas continue forever and ever up in either direction, unless it's in some kind of context of a word problem. So this equation matches this graph, and I need to go ahead and admit my mistake here. This graph, yes, has arrows right here, but the mistake is that this graph actually matches the equation negative 2x plus 8. Forgive me for that. All right, let's go back over here. The a value of an equation is always in front of the x squared. So the a value is 1, the b value is negative 2, and the c value is negative 3. When we look at an equation, there will be two things that we can quickly see or know about the parabola. The first one revolves around the a value. If the a value is a positive number, it could be a 1/2, positive 1/2, positive 2/3, positive 7. If this is a positive number, then the graph will open up, just like this. The other quick thing that we can see from the equation is the c value corresponds to this point right here, this same number, which we call the y-intercept. Very quickly, take this equation, fill in the a, b, and c values. And make a note that if the a value is a negative number, then it will face down. Or I should say open down. Okay? And then hopefully you made the note that the c value always corresponds right there to that number. All right, some other very familiar vocabulary that we'll talk about real quick is x-intercepts, zeros, roots, and solutions. All of these refer to the same thing, which is the place where the graph and the x-axis intersect. So the solutions are -1 and 3. Quickly do the same over here. All right, so still in reference to this graph right here, we need to determine if this graph has a minimum value or a maximum value. So if you thought of this as a portion of a roller coaster and the cart is going right here and then all of a sudden it loses momentum and you get stuck right here, would you be saying, oh, I'm at the minimum point of the roller coaster, or am I at the maximum point of the roller coaster? Hopefully you're saying the minimum. Okay. Every parabola that opens up will have a minimum value because it kind of bottoms out the lowest point. Now, if I was stuck right here in a roller coaster and I call someone to try to help us out, then I would need to tell them where we were at. And we would look over at the y-axis and say, I am at the minimum value of this roller coaster and I'm at -4. So any parabola that faces up will have a minimum value. I think I just misspelled that, so just correct it on your paper. Minimum value of -4. All right, this is still a very important part of the graph. This place right here that we're saying goes from a decreasing to an increasing portion of the graph. It's called the vertex right here. There's a dot right here. That's an ordered pair. That's a location. So this point where the graph turns, so the vertex is the turning point of the graph. And there's actually a dot there that we could give an xy coordinate to. So the x value is 1 and the y value is -4. 1, -4. So the vertex is located specifically at 1, -4. Also, the vertex marks a place where the graph turns, which gives us this idea that there is this vertical line that goes through the vertex and it splits this graph in half. So if I took my paper and folded it on the dotted line, this half of the graph would fold on top of the other half of the graph. That's called a line of symmetry, but in algebra we call it an axis of symmetry. It will always be a vertical line that splits the graph in half. We have a vertical line graphed right here. We've had a lesson that talks about this acronym VUX. So a vertical line has an x equals equation. This vertical line has an equation that starts out as x equals, and as I drew the vertical line up towards the x-axis, it went through 1. So the equation is x equals 1. Now, before we go on, I would like for you to pause the video, and I would like for you to use this graph to determine if it has a maximum or minimum value, write out the vertex, and draw and label and write the equation of the axis of symmetry. All right, last thing we need to cover is domain and range. The domain is the x values of the graph. And when thinking about the x-axis runs left to right, so the domain of a graph, we should be considering how far left does the graph go and how far right does the graph go. Well, typically our domain or range starts out looking like a less than symbol, an X, and a less than symbol. And we usually have to pick out the numbers that represent the farthest left that this graph goes. And so if we see that the graph continues to go wider and wider and wider and wider, then there's not a number. We would say, oh, that goes way out here to -infinity. The same thing for the right. It starts getting wider as it increases and it continues to get wider. So there's not a farthest right number that the graph goes, and so we'd say, oh, that goes out to infinity. But this isn't answers that we see in Algebra 1. If there is not numbers on either left bound or right bound of this graph, we just say, oh, that's all real numbers. Our domain would be considered all real numbers. Okay, for the range, that's the y values. And if you think about a graph and the y-axis, we are talking about how low the graph goes or how high the graph goes. So range, we're thinking low to high. All right, again, our domain and range begins with a less than symbol. Since it's range, it'll be a y value, and another less than symbol. And we have to determine the number that represents the lowest place on the graph, which is right here. And if we look over to the y-axis, the graph is the lowest at -4, and we have to ask ourselves if the graph can equal -4, and it does. And now I have to follow the graph up to its highest point, but these arrows will push this pin higher and higher and higher, so there's not an exact number that this graph stops. And so we would maybe say, okay, well, it goes to infinity. But again, in Algebra 1, we don't use the infinity symbol, so we would need to box off the portion that we can't use. We can't use an infinity symbol. So we would say that this is our range. However, when we get to a multiple choice situation, they always start our range with a y value, and then we would need to turn the inequality so that it still opens up towards the y value, and then the -4. And so we would be saying that the range is greater than or equal to -4. So at -4 or above.